Hi everyone, welcome to regression analysis lecture. For this session, we will be discussing about variable selection. So, before explaining how to do the variable selection, we will start with the problem. Okay, what is the problem in variable selection? So, given a large number of covariates, let's say x1, x2, x2 up to xp, provided for explanatory variables of y, where y is the response variable, in a multiple regression model. The problem is that the first one, do we really need to put all the covariates in the model? And then because the consideration is that we have the parsimony principle, that is, we want the model to be as simple as possible, yet as accurate as possible. Okay, so if the model can be explained only by a small number of variables, why do we need to put in lots of variables in the model? Okay, so we try to avoid a more complicated model. So that's the problem, the first one. Okay, and the second one is that, let's say we want to reduce the variable number. Okay, so we don't really need to put all the covariates in the model. Then how can we select a subset of variables? For example, instead of P, we will select K, where K is less than P. Okay, we will select K variables such that the constructed model is the best one. We will see later why I put quote best in this, why I put the quote sign for the word best, because what is the best criterion? What is the criterion for best in this problem? We will see it later. Okay, so that's the problem that needs to be tackled by the variable selection methods, and for this session we will learn one way of doing the variable selection. Okay, so basically what we will be discussing is about the stepwise procedure, but since stepwise procedure is kind of like a combination of backward elimination and forward selection, so we will be discussing about those two approaches first. Okay, so now what is the backward elimination? Okay, backward elimination is the process that we start with a full model. Let's say we are given P explanatory variables, so we put all those variables in the model. And then we will proceed by eliminating the variable one by one until we get the final model given by this one. Okay, that should be a simple one. Okay, and then what about the forward selection? It is on the opposite of the backward elimination. The forward selection, we start with the null model. We call it null model because the model does not contain any covariate at all, so it just contains the intercept. And then we add the variable one at a time until we get the final model that should be the best one relative to the null model. How do we add that variable? We will explain it later. And then the last one is that the stepwise procedure. If we look at it, it looks like exactly the same with the forward selection, but then later on we will see what's the difference in the process of adding each of the variable. Okay, so now we will go to the procedure of backward elimination. I will just move into this file. So like what I told you before, let's say we have like P explanatory variables. Let's say in here for the illustration purpose, I only put 5 explanatory variables. So P equals 5, and we have the response variable Y. Okay, so the first step here is that, let's say it's step no, we start with the full model, that is by putting all of the variables into the model. So we have this one, y equals beta naught plus beta 1 x1 all the way up to beta 5 x5. Okay, and then the first step is that we need to take out one variable that is least important in explaining why. Okay, and how do we say that it is least important? Is that by doing partial t-test for each of the coefficients related to their explanatory variables. So in here, we will be testing, here is that, okay, beta naught, beta 1. So we will be testing here, it should be here is that we will be testing whether beta 1 equals 0 or beta 2 equals 0 or beta 3 equals 0 or beta 4 equals 0 or beta 5 equals 0. Okay, and then after that, okay, this is our hypothesis, right? I just write this is the null hypothesis. Okay, we will be testing this null hypothesis, and then we do the procedure of doing the partial t-test, and then we get the t-value from the test. Okay, this is just some made up numbers. Okay, so then let's say here we have that the t-value for this, for testing beta 1, let's say we got 12 and 32, 21, 32 and 42 for beta 1 up to beta 5 respectively. And let's say the t-table, of course, that in doing the testing we have to compare this t-value with the standard or the reference distribution, that is the t distribution with degrees of freedom of n minus n minus 1. Okay, so then let's say this is because this is just for the illustration. I don't want to bother looking at the table, and actually because we also don't know the sample size. Okay, so then let's just say the made up or the decided t-table or the reference is 20. So which means that if the t value is greater than the t-table, we will just exclude the corresponding variable, because it means that the regression coefficient related to that variable is not significantly differ from 0. Okay, so from here we see that this one is less than 20, our reference number here. So our decision is that we will exclude x1 from the model. So x1 is the first one to be eliminated from this model. Okay, then we finish with step 1, we go on to the next step. Okay, now as a result from step 1, we exclude x1, so our model is now only consisting x2, x3, x4, and x5. Okay, and again we repeat the exact same procedure here. So in here, in here, we refit the model using these 4 variables. So that's why I changed the symbol for the coefficients. At the first one, I used beta. Now I used A0, A1, A2, A3, A4, because that the number of variables or the variables that included in the model, we change it, then there should be also changes in the estimated parameters. Okay, so that's why I changed the symbol here. Okay, and then again we repeat the same procedure. We are testing the coefficients for x2, x3, x4, and x5. So we have this hypothesis, and again still calculate the t-value, and then with the reference of 20 here, remember this is just a made up number, okay, for the illustration. And then we let's say this one, for testing this hypothesis, we get the t-value is 15, which is less than 20, our reference value. So then our decision is that we will exclude or we will eliminate x4 from the model. As a result, when we go to step 3, then our model consists only 3 remaining variables. are x2, x3, and x5. And again, we will refit this model, so then the estimated parameters might be changed. So that's why we changed the symbol here. Okay, repeat that again, the same procedure, and then let's say at this step we got the t-value is something like this. None of them is greater than or is less than the t-table. So which means that all these variables are contributing significantly in the model to explain the response variable. It means that all the variables should be retained in the model, so we stop the process and the final model is this one. Okay, so that's the end of the backward elimination procedure. If, for example, in here we get, for example, like the t-value for this is 10 less than 20 is in the non-rejection region, so again we will exclude x2 here, that is associated with c1. We will eliminate that variable and then we go on until we get the final model. Okay, but let's say for this scenario we stop up to this point, so this will be our best model for the backward elimination procedure. Okay, now we proceed on the second procedure, that is what we call the forward selection. So I think that now you can imagine how this procedure works, because it's just kind of like the opposite way of the backward elimination. Okay, so for example here again with the same explanatory variables x1 up to x5 and the response variable y, instead of starting with the full model, now we are starting with the null model. Okay, so it just consists of the intercept. And then in the step 1, we try to fit a model with just one explanatory variable. So because we have 5, it means that we will fit 5 models, 5 simple regression models. So we will name it M1 up to M5. Okay, so the first model with x1, the second model with x2, and so on. And again, from these 5, which one should be chosen? Of course, that should be the best one. And the criterion for the best one is that the one with the most significant result according to the partial t-test, or we can just refer to the t-value, should be the one with the biggest value of t, because in the absolute value. Okay, so we are doing this hypothesis here, and then let's say again these all are just made up numbers, and then we have these values, and then so we just look at the biggest one. Let's say x5 gives the biggest t-value, so then our decision is that to choose x5 in our first process. And then in the next step, now we've got x5 for our first variable, and then what are the variables to be included in the model? We kind of like repeat the same procedure here. So we already have the model y equals intercept plus something times x5, and then we just need to add, okay, what if x5 and x1, what if x5 and x2, what if x5 and x3, and what if x5 and x4. Okay, and then we put different symbols for the parameters, because again different combination of variables will give like different parameter estimates. So now what we need to test is that, okay, now x5 with x1, do does it really x1 can work together with x5, something like that we need to check. So then in the sense that we need to test the hypothesis whether a2 in this case equals to 0 or not. So the same thing applies for the other variables. So we have these hypotheses. And let's say again we do some calculations and then we got these numbers. Again, these are all just made up numbers. And then so we see the one with the biggest t-values means that the one with the smallest p-value that leads to the rejection of the null hypothesis. So in this case, we will just choose x3 to be included in the model. Okay, so at the end of step 2, we have kind of like we already chose two variables x3 and x5. So for the step 3, we move forward. What variables should be included again in the models in addition to x3 and x5? So x3 and x5, we can probably add x1 or x2 or x4. Okay, so we have those three options. And again, when we put the three of them together, is it x1 or x2 or x4? Are they kind of like giving contribution to explain why? So it means that we need to check again whether the corresponding coefficient is 0 or not. And let's say after doing the calculation, we get the t-value like this. Let's say, remember, these are all just made up numbers. And then, according to this, the t-values are small. And then if we compare it, for example, with the t from the reference table with the, degrees with the corresponding degrees of freedom, let's say this is less than the critical value, so it leads to the null rejection of the null hypothesis, which means that adding x1 into this model does not contribute really well, so don't need to add x1. The same thing also applies by adding x2 or x4. Okay, because none of them, when they are added to the model, doesn't give a significant contribution, so then we will just stop here. Means that no more variables, when they are added to the model, they are not really contributing really well, so better stop. And then our decision is that we will choose this model as our final model, just consisting x3 and x5. Okay, so that's how forward selection works. Now we've got the idea of how backward elimination works and how forward selection works. What about the stepwise procedure? Okay, it looks really exactly like the forward procedure, but what makes it different from the forward procedure? Okay, let's have a look at here. For the stepwise, okay, so actually I didn't put it like in here the step null, but actually we can do that if you'd like. So I just here proceed straight away to step 1. Okay, so this is just like the forward procedure. Okay, so let's say in here the decision is that we choose x5 to be included in the model. So then in step 2, x here it means that explanatory variables. Okay, so then we move to step 2. Now we've had x5. What else needs to be added here? Again, exactly the same procedure as the forward selection. And then here the decision is that we will add x2. Okay, so in here at the end, or not really the end, so up to here we say that we will have x5 and 2 in our model. Now, from here is a little bit different with the forward selection. While if in forward selection we go straight away to step 3, in the stepwise we are not doing that. Instead, now the first one chosen is x5, and then we add x2, and then after adding x2 to the model, we have to go back and check again, is x5 still relevant to the model when um, when x2 is included in the model. So then we have to check here the coefficient of x5 is b2. So we have to recheck again whether b2 is still significantly different from 0 or not. Okay, and the result is that, for example, if the null hypothesis, if this null hypothesis is rejected, then okay, that's good. You got x2 and x5, and then you can go to step 3. However, if the null hypothesis is not rejected, then we should replace x5. You might ask, why can it be like that? I mean that in the first step, x5 is the best one, but then when x5 work together with x2, then x5 become non-significant. The answer is yes. In the next session, I will show you example of how this can happen. Okay, so then if the null hypothesis is not rejected, means that beta 2 is not significantly different from 0, means that x5 is not really contributing well in the existence of x2, then we should replace that x5. And the options are just the remaining 3 that haven't been chosen, that is x1, x3, and x4. So now, get rid of x5, eliminate x5. Now you have x2, and then try to match x2 with x1, x3, and x4. This is kind of like similar procedure like at the first part of step 2. Again, check it, do your hypothesis testing, and in here choose the best one to accompany x2, and then in this scenario it is x3. So then the decision, if we go to these steps, is that okay, the one that we will proceed in step 3 is x2 and x3. Okay, but then let's say in step 2 our decision is here. Okay, let's say it is this one. Okay, so then we have that x5 and x2 as an input in step 3, and then we try to add one more variable at a time. What if we add x1, what if we add x3, and so on. Again, repeat the same procedure and then choose the best one. Let's say in this scenario is x4. So in this case, we have that in the end we have x5, x2, and x4. But then again, this is where it's different with the forward selection. In the existence of x4, we have to recheck again the condition of x5 and x2. So then we have to check whether c1 equals 0 and whether c2 equals 0 as well. Okay, check it one by one. If the null hypothesis for these two tests are rejected, then we can go to step 4 and then repeat the same procedure. If the null hypothesis is not rejected, then, for example, the null hypothesis of C1 equals 0 is not rejected. C1, this is for, okay, let's just C2, okay. Okay. If the null hypothesis for this, the one with the red font, is not rejected, means here that x5 is not contributing significantly in the existence of x4 in the model, then we should replace x5. We replace x5 with the remaining variables that haven't been chosen, that is x1 and x3. Again, we repeat the same procedure and then choose the best one to accompany x4. The same thing applies if C1 is not rejected. Okay, so then after this, whatever the decision, we go to step 4 and then we repeat the same procedure again, and then we will stop when we add more variables and then the test is not significant. Okay, so that's about the stepwise procedure. And then so it is expected that the final model is uh, a better one. Okay, but there are some caveats that we need to consider when we are using the stepwise procedure. It includes too many individual t-tests that might leads in the inflated type 1 error, and it only considers linear function while probably there exists any other functional relationships, for example higher order terms. So we recommend that you use the the stepwise procedure only when we have like kind of like a large number of variables, and then it's kind of like blindly selecting variables from that set of variables. What you really need to do is actually do the model building. So it means that we need to have a little bit understanding on the context of the problem, and then do some visual representation of the data. We will discuss it in other session. Okay, so that's the end of this session. The concept of variable selection, and then next we will do some data processing in R on doing the variable selection.